A robot that remembers your face, another that's already doing chores in real homes, and another one built to run into disaster zones. And finally, an all-new system that moves with zero motors, powered purely by heat embedded in its own material. 4 robots, 4 teams, all announced in the last 2 weeks. This is not a concept video. This is April 2026, and artificial humans are actually here. Realbotix Vinci, the robot that looks you in the eye. Let's start with the one that honestly gave me the most pause when I first read about it. Realbotix is a US-based humanoid robot company, and on April 8, 2026, they announced the delivery of their first robot equipped with a brand new system called Vinci to none other than Ericsson, the global telecom giant. So what is Vinci? It's a patented AI vision system built directly into the robot's eyes. Literally. Cameras are embedded inside the robot's eyes, and that's not just for aesthetics. The robot can maintain real eye contact with you, and when you come back to talk to it a second time, it recognizes your face. It remembers that it talked to you before. It can pick up a conversation where you left off. Think about what that means. Most robots today respond to whoever's in front of them like you're a total stranger every single time. Vinci breaks that. It tracks engagement over time, reads emotional cues, detects motion, identifies objects and colors, and responds based on all of that in real time. Realbotix CEO Andrew Kagel said the goal is to bring visually aware humanoid robots into real enterprise settings, and the Ericsson deployment is proof it's not just a pitch deck. It's already out there. Personally, I think this is one of the most underappreciated developments in this whole wave of new robots. Eye contact and memory sound like small things, but they are the core of how humans build trust with each other. A robot that can do both changes the entire dynamic. Realbotix's robots, primarily their flagship called Aria, are aimed at customer engagement, clinical data collection, training, and enterprise showcases. And Vinci can be added to any of their models. So this isn't a one-off, it scales. UniX AI Panther, the robot already living in your house. This one is actually happening right now, and I think it deserves way more attention than it's getting. UniX AI is a Chinese robotics company founded in 2024 and based in Suzhou, and on April 8, 2026, they unveiled the Panther, their third-generation full-size humanoid robot. And they didn't just unveil it, they started global deliveries at the same time, and they have a video of it operating in a real, unmodified home. Not a lab, not a staged environment, an actual house. Panther is a wheeled, dual-arm robot. It doesn't walk like a human. It moves on an omnidirectional 4-wheel drive chassis that lets it slide sideways, spin in place, and get into tight spots without needing a wide turning radius. This is a deliberate design choice. UniX AI decided early on that most of the useful things a home robot needs to do happen indoors, and wheels are simply more reliable and stable than legs for that kind of work. I actually respect that pragmatism. The arms are where it gets interesting. Panther has 34 degrees of freedom, the world's first mass-produced 8 degree of freedom bionic arms, and an 80-centimeter vertical lift range, meaning it can reach from the floor all the way up to multi-tier shelves. It runs on a 48-volt power platform and can operate continuously for 8 to 16 hours. Each arm handles a 12-kilogram payload. The robot's brain is what UniX AI calls the Trinity architecture, 3 AI layers working together. Uniflex handles generalizable imitation learning. Unitouch handles visuo-tactile fusion, so the robot can actually feel what it's grabbing. And Unicortex handles long-horizon task decomposition, which is a fancy way of saying it can plan and execute multi-step tasks without getting confused halfway through. In real household testing, Panther woke a user up, made the bed, prepared breakfast, cleaned the whole home, and organized objects, all without scripting, all in a completely normal, unmodified house. Since 2025, UniX AI has been in mass production, consistently delivering over 100 units a month. Their previous model, Wanda 2.0, is already deployed in hotels, retail, and property management. Panther is the next step, and that step is right into your living room. This is the one I'd personally put my money on for near-term, real-world adoption. IHMC Alex, the robot that goes where humans shouldn't. Now we switch gears pretty hard, because while Panther is about making your home easier to manage, Alex is about something much heavier. The Institute for Human and Machine Cognition known as IHMC, is a not-for-profit research institute out of Pensacola, Florida, and on April 10, 2026, they officially introduced Alex to the public at an open house. Alex is a full humanoid with arms, legs, a torso, and a head, with a neck. The only thing it doesn't have is a face. They actually ran a competition at the open house asking kids to design one. I genuinely love that detail. Alex was built on the foundation of IHMC's previous robot, Nadia, which gained some YouTube fame for playing ping pong and boxing. But Alex isn't a lab toy. Alex is a multi-year, multi-million-dollar project funded by the U.S. Office of Naval Research, and its purpose is to go into places where humans would die. Collapsed buildings, military operations, disaster zones. The kind of environments where sending a human first responder is genuinely dangerous. IHMC wants Alex to serve as what they call a human avatar, a robot that a first responder can operate from a safe distance, that can navigate rubble, open doors, climb stairs, and handle the chaos of an emergency scene. Here are the specs that matter. Alex weighs 85 kilograms with the battery, about 187 pounds, which is 15 kilograms lighter than Nadia, thanks to fully custom-built electric actuators developed in-house. It runs on electricity, not hydraulics, which makes it untethered and portable. It has 19 degrees of freedom, high-speed joints that can hit 9 radians per second, and wrists with up to 300 degrees of motion. IHMC's commercial partner, Boardwalk Robotics, had already previewed a legless version of Alex back in November 2025 for industrial and manufacturing use. The full-legged version, built for extreme environments, is what's being developed now. I find Alex fascinating because it's solving the hardest version of the problem. Making a robot that can hand you a coffee in a hotel lobby is one thing. Making one that can walk through a structurally compromised building and relay information to rescue teams in real time is something else entirely. IHMC has spent 2 decades building toward exactly that moment. Princeton's soft robot, movement without motors. And then there's this one, which is, in my opinion, the most quietly revolutionary thing on the entire list. On March 20th, 2026, a research team at Princeton University published a paper in the journal Advanced Functional Materials introducing a soft, rigid hybrid robot that moves with no motors, no gears, and no external air pumps. Zero. The robot is powered entirely by heat. The material they used is called a liquid crystal elastomer. It's a polymer, so it's flexible, but its internal molecular structure is ordered, more like a crystal than a rubber. What makes it special is that when you heat a specific zone of this material, the molecules in that zone rearrange and the material contracts in a programmable way. The Princeton team 3D printed this polymer in precise patterns, creating hinges inside the material itself. When electricity runs through embedded circuit boards and heats specific zones, the hinges fold. When the heat stops, they unfold. Repeat forever. As a demonstration, they built a robot shaped like an origami crane that flaps its wings using exactly this principle. The crane moves, repeatedly, without wearing out, without a single motor. The critical technical breakthrough was integrating the 3D printed liquid crystal elastomer with commercially manufacturable flexible printed circuit boards, so they could control exactly which zones heat up and when. They also embedded temperature sensors for closed-loop control, meaning the system monitors its own temperature in real time and adjusts accordingly. The researcher who drove this project, David Brushadsky, described it as an integration of material science, robotics, and manufacturing. He also released a software tool that lets other designers create their own robots using this method, which is a genuinely generous contribution to the field. So what does this unlock in practice? Think medical devices that move inside the body with no rigid metal components. Think robots working in extreme environments like deep underwater or inside chemical tanks where motors would corrode and fail. Think miniaturized robots too small to fit conventional actuators. This research doesn't build a robot that makes your breakfast, but it might eventually live inside prosthetics, surgical tools, or micro robots that do things no conventional machine ever could. 4 robots, 4 completely different problems solved, all in the same 2 weeks. One that knows your face, one living in your house, one walking into war zones, one that doesn't even need moving parts. None of these is the finished version of an artificial human, but I'd argue we just saw 4 different pieces of one snap into place. And that's not something I expected to be saying in 2026.